In the last period, we have discussed preparation methods of alcohols. Now, next point, we are going to discuss physical properties of alcohols. Now, in case of alcohols, lower alcohols, they are mainly found in liquid state. They are colorless, liquid state and having distinct alcoholic smell here. While higher alcohols they are found in solid state here. So this is about the state of alcohols. Now the most important point that we are going to discuss here, that is the boiling point of these alcohols. Boiling point of alcohols. Because this is very important as far as your JEE, NEET or CET considered. It is very important property. Questions are asked here on this property here. So in details we will discuss this property, that is boiling point of alcohols. Now here, in case of alcohols they generally have higher boiling point than their corresponding hydrocarbons. Corresponding hydrocarbons, that is alkanes, alkenes, alkynes. Then next, family alkyl halides, ethers, aldehydes, ketones. So, compared to this family's boiling point, alcohols have higher boiling point here. Now, why alcohols have higher boiling point? Because in case of alcohols, there is presence of this OH group here, and this hydroxyl group, this is highly polar group here, because there is greater electronegativity difference between oxygen and hydrogen here. That is, the electronegativity of oxygen, it is greater than hydrogen. And so what happens here? Polarity develops here on this hydroxyl group. That means here, this oxygen, it acquires partial negative charge, hydrogen acquires partial positive charge here. That is, poles are developed here, positive and negative, like we say, South Pole, North Pole. Similarly here, such poles are formed here, and when such poles are formed here, then that compound, it is said to be the polar compound. Yeah. So alcohols are polar here. Now consider number of alcohol molecules. Now what happens here? That is, consider, I will take here this, that is, this is one alcohol molecule, or consider here this is another alcohol molecule, or for example, consider this is another alcohol molecule. Now, in alcohol molecules, what happens here? That is here, this hydroxyl group, it develops polarity, that means it develops partial negative, partial positive charge here. Oxygen partial negative, hydrogen partial positive. Now what happens? That is, positively charged hydrogen of one alcohol molecule is strongly attracted towards negatively charged oxygen of another alcohol molecules here, because both are the unlike charges. And so here electrostatic force of attraction develops here between these that is the two molecules, they are joined by bridge here. This is one type of bridge only. This hydrogen bond, intermolecular hydrogen bond, which attach these two molecules here. So now these hydrogen bonds, they are very very strong here, and so number of alcohol molecules, they are held together by these strong intermolecular hydrogen bonds here. And so due to this hydrogen bonding, what happens here? These alcohol molecules, they associate together here. Associated liquid. Do you know associated liquid? Those liquids in which the molecules are held together by such hydrogen bonds, they are said to be associated liquid. So alcohol, it is a associated liquid. Benzene, it is not associated liquid because it is non-polar. And so now here, that is the energy required to break this bond, that is very high energy is required here. As you know, we take boiling point. We take means what here? That is, we supply energy here. How energy is supplied? In the form of heat. So when boiling stage will come, that is when the molecules held together by that force, when that force overcomes or that force gets break, then the molecules get separate, and then we say that it is its boiling stage. So here energy is supplied in the form of heat to break this bond here. Now what happens? Since these bonds are very very strong, and so the energy required to overcome these forces here, high energy is required. That means high heat is required here. And so therefore these alcohol molecules, they have higher boiling point. Generally, while studying in organic, boiling point, generally we consider its van der Waals force, and another we consider its electrostatic force here. So now here, in case of, if we compare hydrocarbons, in case of hydrocarbons, such type of hydrogen bonds are absent because they are non-polar here, generally here. And so therefore, that is their boiling point, it is low here compared to the alcohol corresponding here. That means if we take ethyl alcohol and hydrocarbons say ethane, so the boiling point of ethyl alcohol, it is greater than ethane here, corresponding here. So therefore, that is alcohols have higher boiling point here. Is it clear? Okay. Now next here, that is here, if we take isomeric alcohols, and then what will be the boiling point order in case of isomeric alcohol? So for example, consider here this, I will take, that is here, consider a compound having molecular formula here C4H10O here. Sorry, C4H10O. Now I will show its, first of all I will show its isomers here. Isomers, that is this one isomer here, that is for example, that is for example N-butyl alcohol, that is C4 consider here this. I will show here another isomer here, that is tertiary butyl alcohol. Now these are the isomers here. Here, that is of C4H10O. Now here we have to see the boiling point order here. Now here, that is the boiling point order, it is, that is primary alcohols here, they are having higher boiling point than secondary alcohol, and they are having higher boiling point than tertiary alcohol here. That is the boiling point, for example, in this isomer, the boiling point of N-butyl alcohol, it is greater than secondary butyl alcohol, it is greater than tertiary butyl alcohol. What happens here? That is here surface area is greater here. And so due to surface area, although in all these three isomers hydrogen bonds are present here, but along with hydrogen bonds there is presence of what we call force of attraction. Force of attraction in between molecules. Now as you know, that is the what we call force of attraction, it is directly proportional to surface area. And so greater the surface area, greater will be the what we call force of attraction. And so higher will be the energy required to overcome these forces. And so therefore primary alcohols, they are having higher boiling point than secondary alcohols, they are having higher boiling point than tertiary alcohol. So this point also you have to keep in mind. This is very important here. MCQ is also asked here, which of the following is having higher boiling point here, or highest boiling point here? Is it clear? Okay. Another property in boiling point of alcohols, that is here, as the molecular weight goes on increases, their boiling point goes on increases. This already we have seen here, that is as the molecular weight increases, its boiling point goes on increases. So this is about the boiling point of alcohols. Is it clear? Okay. Now we discuss another property here, that is the solubility. Another, that is solubility here. Now here, generally lower alcohols, they are soluble in water here. They are soluble in water. What happens here? That is, consider this alcohol here. And so, for example, consider here, that is this is water. Now what happens here? That is alcohol, it is a polar. Just we have discussed here. That is in case of alcohols, oxygen acquires partial negative, nitrogen acquires partial positive charge. Similarly here, water molecule, it is also a polar solvent here. What happens in case of water molecule? Here there is a electronegativity difference between oxygen and hydrogen, and so therefore here again poles are developed here. That is, hydrogen acquires partial positive charge, oxygen acquires partial negative charge. Here, that is, poles are formed here. And so when alcohol is dissolved in water, then what happens here? That is, positively charged hydrogen of alcohol molecule is strongly attracted towards negatively charged oxygen of water molecule, because both are the unlike charges. So similarly, negatively charged oxygen of alcohol molecule is strongly attracted towards positively charged hydrogen oxygen of water molecule. And so here that is such electrostatic force of attraction develops here. I will show here. That is similarly here, that is oxygen and hydrogen here. So when such types of bonds are formed here, that is any compound, if it is dissolved in water, and if such types of bonds are formed, then we say that so and so compound it is soluble in water. Is it clear? So here alcohols, they form bond with water molecules, and so therefore alcohols, they are soluble in water here. Lower alcohols here. As the molecular weight goes on increases, again their solubility goes on decreases here. What happens here? In case of alcohols, there are two parts here. One part, that is which is involved in bond formation with water molecule. That part, that is called hydrophilic part, water loving part. As you say, that is aquatic plants here, hydrilla for example. It is hydrophilic plant or aquatic plant here. That means that part which takes part in bond formation with water molecule, that is called hydrophilic part. And another part here, that is the part which does not take part in bond formation, that is known as the hydrophobic part here. This one, this is a hydrophobic part here, that is which does not take part in bond formation. Water heating part, we say hydrophobic means water heating, as like the plants which grows in deserts. That is Kaskuta, for example, it is a water heating plant here, or minimum water is required. So similarly here, the part which does not take part in bond formation with water molecule, it is hydrophobic part here. And so the hydrophobic part here, it is alkyl group here. And the hydrophilic part, it is hydroxyl group, which takes part in the bond formation. Now what happens here? As the molecular weight goes on increases here, then what happens here? That is hydrophobic part goes on increases here. That means we say methyl alcohol, ethyl alcohol, n-propyl alcohol. So the carbon chain goes on increases here. Hydrophilic part, that is hydroxyl group, number of hydroxyl group, whether it goes on increases? No. That is hydrophilic part, it does not goes on increases, only hydrophobic part, it goes on increases here. And so therefore, that is as the molecular weight increases here, their solubility goes on decreases here. If the hydrophilic part, that is the number of hydroxyl groups, if they goes on increases, then its solubility will also goes on increases here. Is it clear? Okay. Another here, that is if we take isomeric alcohols here, so what will be the solubility order in case of isomeric alcohol, that is primary, secondary and tertiary isomeric alcohols. For example, consider this one, that is compound having molecular formula again C4H10O here. Now here, these three isomers, N-butyl alcohol, secondary butyl alcohol, tertiary butyl alcohols. Now in case of isomeric alcohols, here the solubility order, here it is, that is tertiary alcohol, it is more soluble than secondary alcohol, it is more soluble than primary alcohol here. Now why it is? Because what happens here, in case of tertiary alcohol, the surface area is less here compared to the primary alcohol. Here surface area is greater here. And so as the surface area increases, its solubility goes on decreases. And so therefore that is, this is the solubility order here. Solubility points are very important. That is the boiling point and solubility of alcohols. Is it clear? Okay. So we have discussed here physical properties of alcohols. Now next we will start with here, that is the chemical reactions of alcohols. Here. Next part. That is chemical reactions of alcohols. So in the chemical reactions, first of all we will discuss here laboratory test here to detect alcohols. Here laboratory test here. That first of all we will see here. Now here, in case of alcohols, here in our syllabus they have given litmus paper test here. Another they have given, that is the reaction with strong base, and another distinguished test is there, that is Lucas reagent test. So first of all, litmus paper test here, that is, then here that is alcohols, they are neutral to the litmus paper. Here alcohols are neutral to the litmus paper. Here why they are neutral to the litmus paper? Because they are very weak acidic in nature, and so therefore they does not show litmus paper test. So you have to keep in mind about litmus paper test. Another here, that is reaction with, that is reaction with metals here, active metals. Now what happens here, if any compound it is acidic in nature, then it reacts with strong base here. That is, but what happens in case of alcohols they does not react with strong base or usual weak base also. That is, they does not react with sodium hydroxide or potassium hydroxide, sodium bicarbonate here. But these alcohols they react with active metals such as sodium, potassium here. For examples here, that is, consider this, we have taken alcohol, and these alcohol it reacts with active metal, say here is sodium here. So what happens here, that is, when it reacts with sodium here, that is, hydrogen is removed here. That is, in case of alcohol here, hydrogen it is replaced by sodium metal, and so here is formation of here, that is this this corresponding sodium alkoxide. Now in case of sodium alkoxide form here, these alkoxide ions here, that is, these are not very stable here, alkoxide ions here, because they does not show resonance here. And so therefore, that is, alcohols, they are weak acidic in nature. Is it clear? Okay. Then again here, although it is very weak acidic in nature, but question is asked here, that is its acidity, that is which of the following compound is most acidic here, or which of the following alcohol is least acidic. So that also we have to discuss here. That is, if we take here for example, consider here this, we have taken this, I will take this example, that is for example methyl alcohol. Here, methyl alcohol, for example, or for example, consider I will take another example, that is for example ethyl alcohol. Here, or for example, consider I will take another example, that is for example isopropyl alcohol, or for example, consider again I will take another example, that is tertiary butyl alcohol. Here, now the most acidic in case of this here, most acidic here. Now here alkoxide ions here form, they are unstable here, and when they will get stable, when the nucleophilicity or electron density gets decreases here, then they will get more stable here. But what happens here, that is alkyl groups, they are electron donating groups. They show positive inductivity. That means they pushes electrons. And so since they pushes electrons, and so therefore what happens here, that is again electron density increases here. And as the electron density increases, then its stability gets decreases. That means here, in case of here, most, if it is to be stronger acid, then there, that is electron withdrawing group must be present here. Electron withdrawing group, what they will do, they will increases the acidity here, and electron donating group here, they will decreases the acidity. Now if we compare this here, alcohols, now here all these alcohols here, there is presence of electron donating groups are present here. That means in methyl alcohol there is presence of this methyl group, or in ethyl alcohol there is presence of ethyl group, or in isopropyl alcohol again there is presence of these two methyl groups, or in tertiary butyl alcohol there is presence of here again is three methyl groups here. So if we compare here this, all these are weak acids, but most acidic in these alcohols here. So the most acidic here, that is the methyl alcohol. It is the most acidic. Why it is most acidic? Because here there is a effect of only one methyl group here. In case of ethyl alcohol, again there is greater effect of ethyl group here compared to methyl group. Again in case of isopropyl alcohol, there is effect of two methyl groups here. In case of tertiary butyl alcohol, there is effect of three methyl groups. That is number of here electron donating group increases, and so therefore the alkoxide ion form, its stability gets decreases, and so therefore that is methyl alcohol, it is a secondary and tertiary alcohols. Here, Lucas reagent test here. Now what test here it is? That is here, these alcohols here, they are treated with Lucas reagent. Here, what is Lucas reagent? That is, it is mixture of concentrated HCl, concentrated HCl and anhydrous ZnCl2, that is zinc chloride here. So this is Lucas reagent, mixture of concentrated HCl and anhydrous zinc chloride here. So here, when these alcohols they are treated with Lucas reagent, then what happens here? That is, this reaction, it is nucleophilic substitution reaction. What happens here? That is hydroxyl group here, it is replaced by chloro group. And so here this formation of this alkyl chloride takes place. Plus again formation of H2O, that is water molecule is formed here in this reaction. So when alcohols are treated with Lucas reagent, then here that is formation of alkyl chloride takes place here. Now the point here it is that the reactivity of these alcohols towards Lucas reagent it is different. Reactivity of alcohols towards Lucas reagent. That means here tertiary alcohols here they are more reactive than secondary alcohols and they are more reactive than primary alcohols here. Now why this reactivity? Because in the mechanism of this reaction here intermediate carbonium ion is formed here. Intermediate. And as you know the stability of carbonium ion it is tertiary greater than secondary greater than primary. And so therefore the reactivity of alcohol towards Lucas reagent that is it is tertiary greater than secondary greater than primary. Now in the laboratory if we take here that is if we have given 3 samples here of alcohols, isomeric alcohols, and you have told to identify in which stage 2 there is primary alcohol is present, in which stage 2 secondary alcohol is present. Then what we have to do here, that is we take this Lucas reagent test here. That is what we do here, in all that 3 test tube we add Lucas reagent here. Now when we add Lucas reagent, then what happens here? That is here the test tube which contains tertiary alcohols here. In that test tube, what happens? Immediately there a white turbidity develops in the test tube. Here, that is the test tube containing tertiary alcohol. In that test tube, white turbidity develops here. White turbidity of this, that is alkyl chloride here. Now next here, remaining 2 test tube here, that in that test tube what happens here? After certain intervals of times, what happens? That is the test tube which contains secondary alcohol. In that test tube, slowly white turbidity appears. Not immediately, after certain intervals of times. Next here, now remaining test tube, here we have to confirm whether it contains primary alcohol or not. Then that test tube, what we have to do here? That is we have to heat that test tube. And after heating what happens? That primary alcohol it reacts with Lucas reagent and so there the white turbidity of alkyl chloride is formed in that test tube. That means heating is required here for the reaction of alcohols test tube containing tertiary alcohols. In that test tube, immediately white turbidity appears here, and that we conclude the given sample it is of tertiary alcohol. Next, after certain interval of times, the test tube which contains secondary alcohols, in that test tube slowly white turbidity develops, and so we conclude that the test tube contains secondary alcohol. Now remaining test tube, what we have to do? We have to heat that test tube. After heating, white turbidity develops here, and so we conclude that it contains primary alcohols. So this is a Lucas reagent test here, that is to identify primary, secondary, tertiary alcohols, and also this reagent test it is very important for board as well as for JEE NEET CET, because question is asked here, that is which of the following will react fastest with Lucas reagent here. Then here, as already I have shown here the order, reactivity order of alcohols, and so by applying this you can detect that is the reactivity of alcohol towards Lucas reagent. Is it clear? Okay, so we have discussed here this laboratory test. In the next period